So as previously mentioned, you actually already know how to do the first bit of this. So allow us to get started on it. And it's also a good day because we don't have incredibly good attendance. So it's not bad that this is all stuff that you already know how to do. All right, so first thing, let's start with what a polynomial actually is. You all will recognize it as soon as you see it, but of course, let's remind ourselves that what it is isn't the definition of it. So the definition is a polynomial is an expression. And I'm going to stop right there for a moment to remind you, what is the difference between an expression and an equation? Isha. Yes, an equation has an equal sign, so it has an answer. Okay? Cool, thank you. Don't write this down, but just quickly remind you. What is the answer to that question? Is there one? No, of course not, because you don't know what x and 7 make. So you can do nothing with that. Okay? What if I did this? Can you tell me the answer yet? No. But can you do something with that now? What would you do? You would say, well, there's one x, there's a second x, so I have two x's plus 7. But can you tell me the answer? No. Once I did this, could you tell me the answer? Yes, by doing algebra. Everybody understand the difference, yeah? So what we're going to be spending this whole next unit, there's almost going to be no equal signs. Okay? We are just going to be simplifying. So it is an expression made up of, and I'm going to put 3 words down here that you already know. Coefficients, variables, and another word that I hope you know, constants. And then, now I'm going to do an example. But first, I'm going to highlight those 3 words. Except, of course, I bet variables is going to highlight in yellow, even though I don't want it to. Of course it did. I want variables to be blue, and I want constants to be green. So now we're going to write out what one looks like. What of those numbers can I color yellow? Jashin. The 3 and the 7. Excellent. What of those numbers can I color blue? The 2 x's. And what there can I color green? The 4. Everyone's cool with that, right? Because I'm going to use those words properly all the time. I'm not going to call it letters. I'm not going to call them numbers. I'm going to call them what they are. So I need everybody to be aware of those definitions. Everyone is, because you should be already. But you will notice there are some things that we have talked about in this class that are not written there, are there? For example, do you see any square roots? No, because irrationals are not allowed. Okay? All irrationals. Now I'm going to do something a little weird on the side. I don't want you to write it down. I just want you to think about it and talk to your neighbor. Just think about this. 2x. Is that a polynomial? Say yes or no question. Is that a combination of coefficients, variables, and constants? Yes. Everyone agrees, right? Okay. So that one is okay. What about this one? Is that one okay? Yep, we're still okay because it's still a coefficient and a variable. And hey, certainly. Yes, of course. So that one's okay, right? Is this one okay?
No.
Yes.
I got 2 no's and a yes. Tavleen's asking somebody, she's doing a mobile shout out, texting somebody if it is or isn't. You switch to yes. Read what comes after that. Square root of 4 is what? 2. So is that rational?
Yes.
Excellent. That one's okay. What about this one? No. What about this one? Is that one okay? Yep. Because that's the square root of 4, isn't it? Okay. So that one's okay. What about this one? Which is it, Nick? You've switched over to no? Pick someone else, but I'm going to keep yelling yeses and nos. Is that okay? No. Why not? Because that 1/2 is going to make the square root of x, yes? And that's not okay. Unless we know what x is. But if we know what x is, it's not an equation, it's not an expression anymore. It's an equation, isn't it? Everybody good? All right. Okay, now we'll come back to what we're doing. A monomial. A monomial is a single term. That's another new word. Which I'm going to underline because I've used all my highlightings already. Pink is hard to read through. You guys know all this anyway, so it's not a big deal. Term. A term is any combo of coefficients, variables. I'm lazy, so I'm writing vars, and constants. I'll highlight them again so we keep the same colors going. Any combination of those things that is connected by multiplication or multiplying. So, everybody cool with that? So I'm going to write an example of one. Is that a monomial? Yeah, because it's a variable, right? Everybody okay? And there's only one of them. Everybody cool? Okay, what about this? X squared. Is that okay? Yes, because it's a variable and squares just multiplies, right? Okay. 2x squared. Is that okay? Why, Aiden? Because it's just multiplying. 2 times x, right? We still okay? All right, what about this one? 3x squared y squared. The definition says any combination of coefficients, variables, and constants that is connected by multiplying. Is that connected by multiplying? So is it a monomial? Yes, because everything there is connected by multiplication. Everybody cool? Everybody can tell me what a monomial is, right? What if I had 27 variables? 7 A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Is that a monomial? Yes. Why? Because it's all connected by multiplying. Everybody good? All right. So, if a monomial is a single thing, a mono one, then what is a binomial? Right. 2 monomials. So I'm using red because I use red for all my monomials here. 2 monomials connected by what? If I have 2 monomials connected by multiplying, then I just have one monomial. So it can't be multiplying, so it must be addition. So x plus 3y. Yes or no? Yes. Monomial connected by addition. Okay? Everybody good? Okay. 3x squared y cubed minus 4a squared b cubed. Yes, why? I said it's connected by addition. That's plainly subtraction. But why is it still okay? They don't go hand in hand. One of them exists and the other one doesn't. Which exists, adding or subtracting? Adding exists. Because what is subtraction? No. That's what we call subtraction when we're in grade 3 and Mrs. Bad Crumble talks about Jashin having 5 apples and Aiden eating 3 of those apples. So how many apples does Jashin have left? And they teach you take away. But what is it really? Adding what? Adding negatives. But math guys are lazy. They don't want to write 5 plus negative 3, so they invented 5 minus 3, which is very confusing to all of you guys. We all know how confusing negative numbers are to the average grade 10 student. Because when I say negative 7 minus 3, half of you say negative 4. And half of you say negative 10. And then I say, what's negative 7 minus negative 3? Half of you say, negative 10. No, that one's negative 4. Because negative numbers are very confusing. Everybody cool? All right. So if that's a binomial, it's 2. What's a trinomial? 3 monomials connected by what? No, because division is just multiplying by fractions. By addition. 3 monomials connected by addition. So, whoa, sim salabim. 3x squared plus 5y plus 7. Easy peasy, right? Everybody's good? I can talk mono, bi, tri all day. I'm not going to because it's very simple. After trinomials, we just call them polynomials. Poly is from the Greek word for many. Many nomials. Nomials from the Greek word for number. Many numbers. Everybody cool? All right, the next thing I'm going to show you is not really important right now, but I want to make sure I show it to you so I don't get in trouble later. Okay? And that is the degree of polynomials. The degree of polynomials is simply this. It is the largest sum. What math gets you a sum? Addition. The largest sum of the exponents of the variables in any one term. So, what do I mean by that? Somebody give me a term. Give me a single monomial that has a variable and an exponent. Go. 7x squared. 7x squared. So now, tell me the degree of that. Why is it 2? Because there's only one exponent. It's got a variable of 2. There's only one variable. It's got an exponent of 2. So there's nothing to add to it. Everybody cool? All right. Now, I'm going to add, with a different color, I'm going to add another term to this. So right now it's a monomial. As soon as I add something, what does it become? A binomial. So now I'm going to add 7x squared y. Now what is the degree? This guy's degree was 2. What's this guy's degree? The largest sum of the exponents of the variables. Why is it 3? Because y has an exponent of 1. So that makes this a degree 3. Everybody cool? Okay, so now I'm going to add a third one in a third color. Plus 8x squared y squared. Now what would the degree of that trinomial be? 4. Everybody cool? Everybody good? All right. And the only reason we use it is because when the polynomials get gigantic at like high levels of math, they like to put them in order. And they like to put them in this order. Biggest degree first and alphabetical. But I don't really care. I just want you to have seen it. Okay? Now I'm off the hook. Right? Okay. Next thing we're going to do is we're going to talk about multiplying these things. You all already know this from the 9th grade, but I'm going to take a moment to make sure you are aware of this in 3 different ways. Well, only 2 really, because I'm not getting out algebra tiles because it's a short day. If I wanted to actually show what this means, not with numbers, to actually physically show it, what math is happening right there? Multiply. So what would this say in English? If you were going to read this to me in English, what would you say to read to me that mathematical expression? 5 times what? X plus 1, right? So you have x plus 1, and you're going to make 5 of them, right? Now, in math, we don't actually do math that way, do we? If I asked you to tell me the answer of 7 plus 5, what is it? Took a while. We got there, though. Way to go, team. 7 plus 5 is indeed 12. Now, really, though, in reality, how many things did I just draw on the page? 1. But that symbol I drew there represents what? It represents 7 things, correct? But we don't write 7 things because it would be really hard to do math that way, wouldn't it? Because if I asked you to do 831 minus 702, 1, 2, 3, 4, up to 831. And then what would you do? You'd have to cross off 702 of them, wouldn't you? And that's stupid. So what did we do? We invented numbers to show that. But what happens when we invent those numbers is they get more and more complicated, which is why we get to the problem of what's negative 7 minus minus 3. No! Negative 4! See what I mean? Everybody see what I mean? The symbols made it complicated. So, back in the day, when Mrs. Bad Crumble was teaching you addition and subtraction, she used little tiny numbers, and she started with blocks, or marshmallows, or apples, or whatever, right? And then your first textbook drew pictures of cookies, didn't it? Right? There's Tasha had a pack of 5 cookies in front of her, and Jake had a pack of 3 cookies in front of her. How many cookies do they have together? And you go 1, 2, 3, 4, 5, 6, 7, 8, Mrs. Bad Crumble. Right? That was how math was, yeah? But numbers get bigger than that, don't they? So when we get to high school and we started dealing with these bigger numbers, some kids had trouble with it. So somebody invented these things called algebra tiles to show you guys how to deal with them. And algebra tiles were so you could actually see what was happening. So just to make sure, I want to show you that. So this says there's 5 times, I'm going to have x plus 1 5 times. So we decided, not we, math guys, decided that they would use this bar to represent x. That bar is an indeterminate length. You don't know how long it is. And they use this little box to represent 1. And they were smart because this bar is a little bit shorter than 5 of these. So it's not really 5 because it's a little bit shorter than that. So that's why this is an x, because you don't know how long it is. Okay? Now, that is x plus 1. We don't color them in because that's what they decided makes them positive. And then I need how many of those? 5. And just like grade 3 with Mrs. Bad Crumble, all of a sudden, you just learned how to multiply polynomials the same way you learned how to add in kindergarten, right? Because now I have how many of those? 5 x's. And I have how many of those? 5. And since they're not colored in, it's positive. And that's multiplying polynomials. Your teacher should have showed you that last year. At least shown it to you. Right? Okay. Then, of course, your teacher hopefully said, but we have a shortcut for that. And that shortcut is exactly what Brianna said. Because when you say it out loud, it makes perfect sense. 5 x plus 1 is 5 times x plus 1, isn't it? So, there were 5. What does it really mean? It means I got to have 5 times x, don't I? Because that's right there, right? And then I had 5 times 1. And I'm adding them because it's all positive. So hopefully your teacher showed you that last year. And then, hopefully, your teacher, he or she, drew these little arrows here. And then, your teacher probably gave it a cute little nickname. I don't know what the nickname is because I don't use cute little nicknames. What your teacher was really showing you was what is on the very next page for you when you turn it over, onto page 120. Your teacher was showing you the distributive property. And hopefully your teacher called it that, because that's what it is. All the other cute little names are not what it is. The distributive property says this. That is the same as x times a plus x times b, which is real easy to understand, isn't it? right? We drew it. It's pretty easy, yeah? The problem with this is when it expands. You guys start to get a little wonky with that. So, because this looks a certain way, if you choose not to learn the proper principle behind it, you're going to be in trouble. So what if this was x and a plus b plus c? Then what would we have? xa plus xb plus xc. What if I went all the way out to the end of the alphabet? Then what would I have? xa, xb, xc, until I get to x, what would it be? No, x squared. Was that you, Brianna? You sneaky, I couldn't fool you. Well, because it would be x times x. So you would write x squared. And then where would that x squared go if we were writing it out properly? No. That's if we were drawing it. If we were writing it out properly, then the x squared would go to the front, wouldn't it? Because it would be the biggest degree. Yeah. Okay, so we're only going to draw once, all right? Because the problem with those algebra tiles is they don't work with any exponent bigger than 2, which is why I don't like teaching with them. Because there's a lot of exponents bigger than 2, isn't there? Right? There's an infinite amount of exponents bigger than 2. And those algebra tiles only work if something is squared. But that's okay. So, what is this saying? This is saying x times 2x minus 4. So, x looks like that, right? And what would 2x minus 4 look like? Well, there's one x. There's a second x. And minus 4 would be 4 little colored blocks shaded in, yeah? And then all I do is I multiply. This x right here is great. There it is, right? But what's happening to it? It's stretching out, isn't it? That's going to wreck it for me now because I hate this program so much. No, I don't hate the program. I love the program. I hate this computer so much. There we go. And what happens here? Happens again. And what happens here? That bar stretches out, but only as far as the little box, right? And what wins? Positive or negative? Negative wins. And what did I get for an answer? This is no longer x. What is it? If that's x and that's x, this is x squared, yes? And if that's x and that's x, this is x squared, yes? And since I have two of them, it is 2x squared. And this is 4x's. But since they're shaded in, what kind of x's are they? Negative. And that is what is actually happening. Now, of course, we don't bother with that because we need to know what to do if the exponents are bigger than 2, right? So we learn also the algebra version of this, which is simply x times 2x minus x times 4. And then, of course, we remember all our exponent laws. X times x is x squared, and we put the coefficient at the front. Minus x times 4, 4x, and we put the coefficient at the front. Everybody's good, right? Great. So the next one should take about 1 second. Don't even bother drawing the picture. What's the answer? 3x squared plus 6x. Right? Okay. And that, ladies and gentlemen, is probably where your grade 9 teacher stopped. Most likely. He or she may have gone on to this. Let's talk about this. When I had x times 2x plus 4, I drew that rectangle, didn't I? And I put one of them down one side, and I put the other one out this side, right? Okay. So, if it works once in math, does it always work? Sure it does. So, this is no longer x, it's x plus 3, right? So how would I draw it? X and 3 little guys, right? And this is no longer 2x plus 4. It's now x plus 2. How would I draw it? X plus 2 little guys. And then does anything change? I still get a big square. There's my x squared. And I get how many of these x's here? 2. And how many down here? 3. Okay, so that's 1, 2, 3, 4, 5. And then, how many of this guy repeat? 1, 2. And then how many? 2. And then how many? 2. And that gives me a trinomial, doesn't it? Because it gives me how many x squareds? 1. And how many x's? 1, 2, 3, 4, 5. And how many little guys? Plus 6. Why is it all adding? Because there's no negatives. Everybody cool? Now, here is where most of your teachers probably stopped in grade 9. I can't guarantee it. I know my grade 9s saw what I'm about to do, but I never gave it to them on a test. I just showed it to them because it's the next logical step, right? So what I have was this, right? If I take away that 3, then what do? It would be x times x plus 2 times x, correct? Everyone agree? Okay. And if I took away that x, what would you do? 3 times x, and then 3 times 2, correct? Everyone agree? Okay. So what does x times x give me? X squared. Not 2x squared, just x squared. What does 2 times x give me? 2x. What does 3 times x give me? 3x. Hey, I already had 2 x's. I'm going to put those x's together because I know that x's go with x's. And what's 3 times 2? 6. Now please look at what we have just done. X squared plus nothing. What's that? X squared. 2x's plus 3x's is what? 5x's. Nothing plus 6 is what? 6. What do you see? They're the same thing, yes? Which then, every math teacher says this next thing. This is called binomial expansion. Because I had one binomial, x plus 2, and then I had another binomial, x plus 3. But what did I really do? I took x and I distributed it, didn't I? And then what did I do with 2? I distributed it, didn't I? So really all I did was did distribution how many times? Twice. Which gives us this cute little acronym that math teachers just love. I don't like it because it only works as an acronym with its fun little name if it's 2 binomials. And it stands for first, outside, inside, last. And here's what it means. 3x plus 2. Is that a binomial? Yeah. And then let's do 4x minus 1. Is that a binomial? So let's do what we just did. We'll do a red line for first. What's the first thing in both binomials? 3x and 4x, right? So what is 3x distributed into 4x? What's 3 times 4? 12. And x times x? X squared. Everybody agree? Great. Now we'll do outside with blue. The outside pair, 3x times negative 1. What's that? Negative 3x. Excellent. Now in green, let's do inside. Those are the inside partners. What is 2 times 4x? Positive or negative 8x? Positive 8x. Hey, I already had some x's, so what should I do? Put them together. I'm going to even write them together so I can't screw it up. Plus 8x. And then last, we're going to do in gray, what's 2 times 1? Negative 1. Negative 2. And then what do I do with my final answer? What's 12x squared plus nothing? 12x squared. What's negative 3 plus 8? Plus 5x. And what's 0 minus 2? And you're done. Everybody cool? Now you guys are smart kids, right? So do what I just did way over here on the left with x minus 1 and x minus 4. But try to cram it in on the left because I want to do something on the right. So let's write that over here. What is the first thing you see? X and x to get x squared. If it helps to draw the arrow, draw the arrow. What is the outside pair? X and 4, and it's positive, so it's plus 4x, yes? What is the inside pair? Negative 1 what? Negative 1x, so I'm going to keep the x's together. And what is the last pair? Negative 4. And what do I do with all that? Collect like terms if you have them. So you're going to get x squared plus 3x minus 4. Is everybody cool? Now the problem with this is, like I said, everybody gives it that name. Oh, it's FOIL. Just FOIL it. I hear people say it all the time. Oh, I'm just going to FOIL that. Which is wonderful if it's 2 and 2. Because it's a first, an outside, an inside, and a last, right? But what if it's this? Is there a first, outside, inside, and last? No, because there's more numbers there, isn't there? But if there's one thing you should have learned from me by now, it is that looks don't matter. Concepts do, right? So in this one, I took the first term and I multiplied it by the first term. So what would be a good thing to try here? Same thing. What's the first term times the first term? X cubed. So I'm going to write those in red. X, well, it's going to maybe show up in red. Who knows? It didn't. X cubed. Now, the first term has done his job, yes? Well, in the old one, we went the x out to the 4, right? So what do you think we should do with this x now? X to the... It went to the next one in line, right? It went to x is 4. So where should it go here? To 3x. And what do I get? 3x squared. Then where should it go? To the 5. To get what? 5x. Now, just to help you guys out, I'm going to change colors. Do I have a new term? So I need to do the same thing. Just like over here, I did everything with the 1, didn't I? Now I'm going to do it with the 2. The 2 goes to the x squared. What do I get? 2x squared. Hey, I already have some x squareds. What should I do with them? Keep them together. 2x squared. Then where does the 2 go? To the 3x. What do I get? 6x. Hey, I already had some x's. Let's keep them together. Then where does the 2 go? To the 5. And what do I get? 10. Then what do I do? Put it all together. What's x cubed plus nothing? What's 3x squareds and 2x squareds? 5x squareds. What's 5x's and 6x's? 11x. And what's 0 plus 10? Easy, right? Does it matter how big I make the polynomial? Don't write down what I'm about to write down. What if I gave you this? X squared plus 3x minus 8 times x squared minus 4x plus 7. What would you do? Same thing, except instead of having only 2 lines, you'd have 3, because you have to distribute this guy 3 times, this guy 3 times, and this guy 3 times. What if I had 4 and 4? 4 times and 4 times, and I'd have 4 lines. Could I do this? Could I do x cubed plus 7x squared plus 3x plus 4 times x squared minus 7x plus 1? Sure, I just have to do 3 distributions. And I would just repeat it and repeat it and repeat it until the end. That's why I don't like using the name FOIL, because it doesn't work once you get bigger than 2. But the concept works, doesn't it? You just keep distributing. I'm done. I want you guys to do, this is where it's going to get a little weird, because tomorrow you have that review that's due for me. Tonight, for homework, you make sure pages 114 to 117 are done, because that's for marks. Right? Tomorrow is a short day. By the time we've marked that and gone over it, because this review takes a long time, because you guys, you think you're real good at it until you actually try to do it. It takes a long time to mark that review tomorrow, because everybody asks a lot of questions. Okay? Then the rest of tomorrow, you're going to finish, only one N, you're going to finish pages 122 to 124, which is what we just learned. Okay? I don't care if you draw the pictures or not where it says use pictures. I really don't. Everybody cool? Now, please notice what I wrote up there for block B. That's what I just wrote down here, yes? Yeah. Unit 3 test is approximately Tuesday next week. I say approximately because you guys know as well as I do, stuff comes up around here all the time, right? I may get told Monday, oh, sorry, we're doing a drill on Tuesday, or something like that. Okay? You know I don't like to give tests on Friday and Monday, so the next logical day for a test is Tuesday. Okay? Also, because Tuesday is a good day for you guys to get the test, because then it's the end of the day, so in case you need a little bit more time, it doesn't screw over your next class. Okay? Everybody cool? All right. So now you can work on whichever one you want, right? If you've already finished this, get this out of the way, and then you can have some time to chit-chat tomorrow. If you haven't finished this, make sure that's done. If you get that done right now before class is over, you got to know homework, because you can finish this tomorrow. Okay? All right.